Hello everyone, today in this video I'll be taking through a machine learning project. We'll be working on Alzheimer disease dataset from Kaggle. The goal of our project is to diagnose or basically classify whether a patient has Alzheimer's or not based on his demographic data, health data and the symptoms. For all those who are new to machine learning, basically classification is a supervised approach in which we try to predict the labels of the input data. So let's begin. As you all can see, I have already imported all the libraries on top. I like to structure my notebooks like this as it makes it easier for the reader to see which libraries I will be using and what to expect down the line. So I'm using standard machine learning libraries like pandas, numpy, matplotlib, seaborn for visualization and scikit-learn for machine learning modeling. Boruta might be an oddball for most of you. It is basically a feature selection library ported from R. I'll be talking more about it when we encounter it down the line. So let's begin by importing the dataset. I'll be using Kaggle API to import my data directly from the Kaggle website. Using this function, I am setting up my API. Then I download the dataset. As the data that we get is in the form of a zip file, I unzip the file, then read the CSV file and make a data frame. After getting data, we'll do standard procedure by seeing what columns we have, using .head function to see the first 5 rows. Default is first 5, you can see 10, 12, 20 or other rows, as many as you want by passing the number of rows you want to see as parameter in the function. You can also use .tail function to see the last 5 rows, which is also default. Similarly, to see more rows, you can pass the number of rows you want to see as parameter. Next, we will be using .info function. This is the info function is very important as it gives the overview of the entire data set. There you can see it tells us how many rows we have. We have 2149 entries, basically indexing from 0 to 2148. Then we have 35 columns. Next we can see we have all the column names, all 35 columns. Our target column is diagnosis. Then you can see the non-null count. Basically it tells how many values are not null. We can see that we have no null values, which will make our data cleaning process easier. Similarly, we can also see the data types. In this data set, the data types, non-null values, everything is pretty much clear, so we won't have to perform a lot of data cleaning. In reality, we will have to perform no data cleaning in this data set. All the values are in int or float format. Basically, you can see the metadata to get better understanding of the data set. Basically, for example, we have categorical values like gender, ethnicity, educational level, and how the maker of the data has categorized these values. For example, for educational level, you have from 0 to 1, 2, 3 and above. For ethnicity, similarly, 0 is for Caucasian, and you can check out the metadata for better understanding or for more detail, the link to which will be present in the description. Next, the .describe function basically tells us the stats of the dataset. I'm using .t transpose as I'd like to have the column names on the left instead of at the top. We have count, mean, standard deviation, min, our quantiles, max value, basically standard stuff. Next, I'll be dropping the patient ID and doctor in charge columns as they are are of no help to us in our machine learning modeling. Basically, that is all the data cleaning we need. So the data set is pretty much already cleaned, so we won't have to do much pre-processing. Next, I divide the data into categorical features and continuous features. Then we will be plotting our categorical features. Basically, don't get intimidated by the categorical plotter class. The the functions look difficult, but it is pretty simple stuff. I like to uh, use OOP, basically classes and functions, to structure all my code, as I feel like these are good practices to adopt. Most of the stuff here are for aesthetic purposes like setting the font size and other few things. Basically, we are plotting a count plot for all the categorical values with diagnosis. What are count plots? Count plots, as the name suggests, basically are the count for each value. For example, if you see hypertension versus diagnosis, it tells us the hypertension has two categories, 0 or 1. Basically, 0, no hypertension, 1, you have hypertension. And it tells us the diagnosis value. Diagnosis, you can see 0 and 1. So basically, for no hypertension, we see that the diagnosis says there is no Alzheimer. Similarly, for 0 hypertension, 1 gives us count how many patients have Alzheimer. So it is the count with respect to the categories and for our target value. So you can see we have all the categorical values here. Other stuff in this is mostly aesthetic. You can check it out on your after watching this video and explore yourself the visualization and check out all the code. Next, I'll be plotting all the continuous distribution for our continuous data. As you can see, similarly, it is also simple histoplot, basically histograms, and KD plot. KD plot basically is this red line. It gives us the distribution of the data. So from the red line or distribution, we can see that our data in most places is multimodal. Multimodal suggests that, for example, if we see distribution of age and frequency, we can see that there are where we have peaks, we have binning or basically clustering. Most of the data is clustered here, so we have bimodal data. Similarly, as for categorical features, you can check out the visualizations and check out the code in detail to see how I have plotted them. Next, we will be moving on to distributing our data. As we don't have to perform a lot of data cleaning, a lot of pre-processing, so we can directly move on to splitting our data set. We'll split into test and train data set. Say if we'll keep test data to 0.3%, 0.3%, sorry, I mean 30% 70, 30-70 ratio. Most standard is 60-40, 30-70, 20-80. I'm keeping a test size to 30. Next, we'll be handling outliers. As I already told, there is not a lot of data cleaning we have to do, so there are no outliers. You can see I'm using Seaborn to plot the box plots. I like the box plots, so you can see all the coloring and all that is aesthetic and is present in the code. You can check it out. We have no outliers. Data is pretty much clean. Next, we can move on to balancing our training set. Basically, balancing is important when we have an imbalance between our between our target values. As you can see, diagnosis, we have almost twice the data for no Alzheimer's. So because of this imbalance, we will have problems when we train our data set. So we have two strategies. We can upsample or downsample. So basically in here I am preferring upsampling. You can also perform downsampling. Downsampling is simply I will cut off all the extra values that I have here randomly so that I have same number of values. In upsampling, I am generating extra data to match the number of counts of the the target that I have more. These topics, for example, balancing and all that, I'll be discussing in more detail in future videos. I am using Smart library to upsample my data. Next, we will move on to feature selection. Feature selection is simple. We are selecting all the important features. For example, I am preferring three strategies here: correlation analysis, mutual information, and the Boruto algorithm. Correlation analysis is simple. Basically, it tells us the correlation between each column and our target. You can see the plot. Next is mutual information. So mutual information tells us how much information a variable gives about another variable. In our case, the other variable is our target variable diagnosis, and we are trying to see how much information all our features provide towards our diagnosis. So you can see we have scores here. Functional assessment has a lot, provides a lot of information. Age provides none. Diastolic BP none. Systolic BP none. So we can see which features provide us information about the target variable. Basically, it's a statistical value or basically methodology which tells us how much uncertainty is reduced by getting the information about a feature from a feature. Now we move on to the Baruta algorithm, our third approach for feature selection. For all of you who are not familiar with Baruta, I'm sure most of you are not. What Baruta does is it automates our feature selection process. I told you how it works is pretty simple. It creates feature shadows, basically all the features that we have. It creates shadows of it, four or more, and then it shuffles those shadows in our with our features. Then it trains a random forest regressor. Basically, multiple decision trees are trained, and then z-score values are calculated. All the features that have a z-score value greater than that of the max of the shadow features are kept. Those who do not have are removed. So you can see we are iterating, have kept 10 iterations. We have 10 iterations. Basically, iteration number 1 confirmed 0. Basically, 0 features are selected. 32 are tentative and move. 32 tentative. Last week we have rejected 26 features. You can see all the dead max, the 5, estimated 69, random state that we have a random forest regressor. Now we have all the columns to drop. You can see the rank, basically support and rank. For example, don't pass the set. It doesn't pass the set test. Age. So you can see here. So you can see here we have support and ranking. For example, age doesn't pass the test and its ranking is 7. Similarly, we have, for example, pass the test. MMSE pass the test, ranking 1. Functional assistant pass the test, ranking 1. So basically, these are the features that have passed the test, which are important, which provide more information, or basically are more correlated to our target or diagnosis in this case. So I have printed all the features as per mutual information and Boruta. So the features to drop as per mutual information, and these are the features to drop as per Boruta. Boruta gives us more features to drop, whereas the mutual information keeps more features. So I'll be dropping as per Boruta. So I have dropped all the features as per Boruta. Next, we will perform feature scaling. Basically, why do we need feature scaling? Feature scaling is an important process when we have a lot of variance in our values. For example, some features have a value from, for example, 0 to 100. Others have 0 to 1000 or 0 to 10,000. Then there is a lot of disparity. To mitigate this disparity, we perform feature scaling so that all our features are scaled to a fixed range or similar range, which prevents bias when our machine learning model is trained. So we are using standard scaler from scikit-learn scaling our trained data. Next, we will be performing feature extraction. Basically, why do we need feature extraction? Feature extraction reduces the dimensionality or basically makes our dataset more informative. What we do is, for example, if you can see, we have 35 columns. After reduction, for example, we have 8 columns or 7 columns, I guess, left. So we have a high dimensional space in which our data points are very sparse. So the information of our dataset is reduced. So what do we do is I am performing PCA here. PCA selects the most important components basically and makes a very information dense dataset. So as you can see, I'll be getting 95% information. Basically, that data that gives us 95% information. And by running the above code, we can see that we will get that from 5 components. So I'm getting all the data that are 5 components and reducing my training and test basically data set. Now I'll be training my model. I've selected SVM for this project, and I'll be performing grid search to get the best parameters. Basically, I'll be performing hyperparameter tuning to get the best parameters. So what grid search does is it takes all the possible combinations of the parameters and gives us the parameters which give the best accuracy. So yeah, so you can see I have the parameters for SVM here: C, kernel, degree, gamma. C basically gives us the trade-off between margin and misclassification. Uh, Kernel, basically we are using the kernel trick, which helps us distinguish or classify between non-linear data. It increases the number of dimensions so that our non-linear data becomes linear, and we can get the hyperplane that distinguishes between the two classes. Next we have degree, gamma, all of that. I'll talk more about SVM, hyperparameter tuning, all these topics in upcoming videos. Now we are performing grid search using scikit-learn, and HPC basically support vector classification. Parameter CV5 basically cross validation. I'm selecting 5, scoring and accuracy. Basically, my best parameters are selected on the basis of accuracy, which the parameters that give the best accuracy are selected. Then fit train, reduce, wire train. As you can see, it performs grid search. Then I get the best parameters. C is 100, degree 2, gamma scale, and kernel RBF kernel. Now I can make the data frame of our results. Basically, I am directly using dot predict using my grid search. I can do so as grid search CV fits the best parameters automatically, as the refit parameter is true by default. If you make it false, then you will have to train your SVM model again using the best parameters. Now I'm giving my testing training accuracy. I'm using accuracy, FN score, precision recall as my metrics to see how my model is performing. Here you can see I made a data frame to clearly picture the accuracy, precision recall, FN score of my training and testing data of my mod. I have made a data frame to show the training and testing accuracies or metrics of my model to see how well it performs in training data and unseen data. So you can see I have pretty well performed. The model has performed pretty well on both training and testing data, almost 90% accuracy. Precision is better on training data, less on testing data. Recall is better on testing data. FN score is pretty much good. The model does not overfit or underfit. It generalizes pretty well, as we can see. So I hope you found this video informative. I have tried to make it concise. So this is all for today. I hope you found this video fun and informative. I've tried to show you all the steps that you need to implement a machine learning project or work on a problem by yourself. All the topics that I have not talked much in detail about, like SVM, what is overfitting, underfitting, cursor dimensionality, Boruta algorithm, hyperparameter tuning, etc. I'll be talking more about them in future videos, so stay tuned and please like and subscribe. Thank you.